Okay, good evening dear students. In last class, we completed the grammatic analysis topic. The grammatic analysis unit is complete. Okay, in today's class, I am going to discuss about the new chapter, that is the thermodynamics, the physical chemistry in the part of physical chemistry, thermodynamics 2. The name is thermodynamics 2. That is unit number 8. Unit 8. Thermodynamics 2. Okay, study yourself the basic concepts of thermodynamics. What is thermo means what, dynamic means what, and process and systems, processes, boundary, and isolated system, closed system, open system, and he you you don't you forget it, then you yourself you remind those basic things. Okay, I'll come directly the your syllabus, the limitations of first law, that is here the need of second law and spontaneous process with examples. In this unit, you in your syllabus, first one is of limitations of first law, second concept is spontaneous process with examples, and different statements of second law of thermodynamics. Different statements of second law of thermodynamics. Right? First concept, limitations. Limitations of first law. First, need of second. Need of second. This is the first concept. Second, spontaneous process. Spontaneous process with examples. Next concept, different statement of second law of thermodynamics. Different statements of second law of thermodynamics. Second law of thermodynamics. Different statements of second law of thermodynamics. Next concept is Carnot cycle. Carnot cycle. This is very important for 5 marks question here. Next, the efficiency of the heat engine. Efficiency of the heat engine. The heat engine. Next, Carnot theorem. This is also very important. Carnot's theorem. Carnot's theorem. Next, concept of entropy. Concept of entropy. And Entropy as a state function. Entropy as a state function. Entropy as a state function. Next concept. Gibbs and Helmholtz free energy function. Gibbs and Helmholtz free energy functions. Free energy functions. Gibbs and Helmholtz free energy functions. Free energy functions and gives free energy functions and useful work. Gives free energy functions useful work and useful work. Next, the significance of free energy. The significance of free energy. Significance of free energy change. In this derivation of Gibbs-Helmholtz equation. Gibbs-Helmholtz equation. Next one, Clapeyron-Clausius equation. Clapeyron-Clausius equation and its applications. And its applications. And next concept, third law of thermodynamics. Third law of thermodynamics. Third law of thermodynamics. Next, Nernst heat theory. Nernst heat theory. Nernst heat theorem. Next, the statement and concept of residual entropy. The statement and concept of residual entropy. Residual entropy. Okay, this is a time duration is 10 hours or 10 lectures. In this thermodynamics second here the first one is limitations of first law, need of second law, need of second law. Second concept, spontaneous process with examples. Third is different statements of second law of thermodynamics. The different statements of second law of thermodynamics. Some scientists are state the different second law thermodynamics. Different, it's stated as a different statement. Different scientific, different, it gives the different statements. And here next Carnot cycle and efficiency of heat engine. Carnot's theorem. This Carnot theorem is very important. Here it comes the adiabatic isothermal. It comes in Carnot's theorem. Next, the concept of entropy and entropy as a state function and Gibbs and Helmholtz free energy functions. Gibbs free energy functions used for work. The use of this Gibbs free energy functions. And then the significance of free energy change here. The significance of free energy change. Here the in this comes the derivation of Gibbs-Helmholtz equation and third law Klepper and next the Clapeyron-Clausius equation and its application and third next concept third law thermodynamics and next the Nernst heat theorem and the statement and concept of residual entropy. In this chapter, the entire chapter you are studying these concepts. Okay, first one here the limitations of first law, need of second law. First concept, first one, what is the state the first law of thermodynamics in your examination arises state the first law of thermodynamics or state the second law of thermodynamics and state third law of thermodynamics or different statements of second law of thermodynamics for 1 mass portions. The Carnot cycle is also 1 mass portion. Before discussion of limitation of first law, need of second law, the what is the statement of the first law of thermodynamics? Here, the statement of the first law of thermodynamics it states that the one form of energy, the one form of energy can change another or into another form, but the total amount of energy remains constant. This is a statement of first law of thermodynamics. Here, the first law of thermodynamics states that the energy can from change, that is, the energy changes from one form to the another, but the total amount of energy of a system remains constant. This is a statement of first law of thermodynamics. Here, the statement of statement of first law of thermodynamics. Okay, first law of thermodynamics. Here, the first law states that energy can change from the statement here states that energy can change energy change from one form to another form. Energy can change one form to another form. One form to another form. But the total amount of energy of a system, but the total amount of energy of a system, the total amount of energy of a system, total energy of a system remains constant, remains same, constant or same, remains the same. This is a the statement of first law of thermodynamics. The first law of thermodynamics states that the energy can change from one form to another form, but the total amount of energy of a system remains the same. This is the statement of first law of thermodynamics. The first law of thermodynamics, here the energy can changes from one to another, but it cannot be created or it does not create it or does not destroy. Here this is the first law of thermodynamics. Here in this first law of thermodynamics, so this has given us the important state functions, that is E and H. The important state functions E and H, and here it suffers from the limitations and drawbacks. For this, according to these E and H, this law has given the important, these are the state functions E and H, and it suffers from the limitations or drawbacks of first law of thermodynamics. This is the limitations of first law of thermodynamics. First limitation, first one. Okay, first statement. The first law does not explain chemical. Here, the first law does not explain the chemical reactions, do not proceed to completion, and it also does not answer here. Here, it does not explain the chemical reactions and do not explain or do not proceed to the completion of the reactions, and it also does not answer it here. This is a first division here. The spontaneous or natural process are unidirectional here. The spontaneous and natural process are unidirectional. It also does not explain anything about the source of heat and direction of flow of heat. Here it does not explain the sources of heat and the flow of heat direction, the direction of the flow of heat. This is a first limitation of first law of thermodynamics. Here first one, the first law does not explain, first law does not explain, does not explain chemical reactions and do not explain completion, do not explain chemical reactions and do not proceed to completion, or do not proceed to, or do not explain, or do not proceed to completion, do not proceed to completion, and also do not explain, and also do not explain or does not answer. Yeah, and also does not answer. And also does not answer. I will write here. Doesn't or does not. This is the first limitation. First law does not explain chemical reactions and do not proceed completion it, and also does not answer here. This one, and also the spontaneous or natural processes, the spontaneous or natural processes is unidirectional. The natural processes are unidirectional. Natural processes are unidirectional. Natural processes are unidirectional. And here it does not explain, it does not explain anything about, anything about, anything about the sources of heat, the sources of heat, the sources of heat, and direction of flow of heat, and direction of flow of heat, and direction of flow of heat. This is a first limitation. Here the spontaneous process or natural process are unidirectional, and it does not explain anything about the sources of a heat. Here, the presence of heat, here it does not show or does not explain the sources of heat and direction of the heat, the flow of direction of the heat. This is a first limitation or drawbacks of first law of thermodynamics. Limitations are another or drawbacks. Drawbacks of this one. First law of thermodynamics. Drawbacks of this one. First law of thermodynamics. And second one, the first law states that all forms of energy. Here, the first law states that the all forms of energy change into one another, but does not define the case or extent of convertibility of one form of energy into a conversion, that is a one form of energy into the another. This is a second drawback of first law of thermodynamics. Second one, second limitation. First law states that first law states that all forms of energy change, all forms of energy change into all forms of energy change into another form, another here, another, but does not define the case of or does not define or the case or extent of convertibility. One form of energy into another. One form of energy into another. One form of energy into another. Here, the first law states that only the changes energy one form to another form, but it does not explain or does not define the case or the extent of convertibility of form of energy, one form of energy into the another form of energy. This is a second limitation. Next, third one. Third limitation, the first law cannot explain that while work can be completely concentrated. Here, if the work can be completely concentrated and into the heat, or a heat cannot be completely converted into work without leaving permanent changes in the system or surroundings. This is a third limitation. First law cannot explain that why work done or work can be completely can into heat, or heat cannot be completely converted. Heat cannot be completely converted into work without without leaving permanent changes in the system or surroundings. Yeah, this is a third limitation. The first law cannot explain that while work can be completely concentrated into the heat, and the heat cannot be completely converted into work. Heat cannot be completely converted into work. The heat you are using, the heat cannot, you are using heat or it cannot be completed, converted into a work without leaving permanent changes in the system or surroundings. This is a third limitation. Next, fourth limitation, fourth one. The first law cannot explain as to all naturally occurring processes. Here, the first law cannot be explained as to all naturally occurring processes. Always tend to change of spontaneously in a direction which leads to equilibrium. This is a fourth limitation. Here, first law cannot explain first law cannot explain as to why all naturally as to why all naturally occurring processes always tend to change spontaneously. Always tend to change spontaneously in a direction which lead to equilibrium. Which lead to equilibrium. Here, the first law cannot be explained as to why all naturally occurring, that is processes, all naturally occurring processes always tend to change spontaneously in a direction which leads to equilibrium. This is a fourth limitation. Next, fifth one. Here, the fifth limitation is the first law does not contradict the existence of heat engine of 100% efficiency or self-acting machines, but on the basis of human experiences, we can say that Such heat engines or machines are not attainable in a actual practice. Here, this is a fifth limitation. These are the five limitations. Here, right? Fifth limitation. Fifth one. First law does not contradict. First law does not contradict the existence of heat engine, the existence of heat engine of 100% efficiency, 100% efficiency, 100% efficiency, or self-acting machines, or self-acting machines, self-acting machines. But on the basis of, but on the basis of human experience, on the basis of human experience, we can say that, we can say that such heat engines, such heat engines or such heat engines or machines are not attainable, or such heat engines or machines are not machines are not attainable in natural practice. In actual practice is not attainable in actual practice. This is a fifth limitation. Here, the first law does not contradict the existence of heat engine of 100% efficiency. Here, given the 100% of efficiency, it does not explain the first law of thermodynamics or self-acting machines, but on the basis of human experience, here we can say that this is such heat engines or machines are not obtainable in actual practice here. The greater values of the second law, here comes the greater values of second law as the chemist is concerned lies in the fact that it forms the basis of predicting whether a particular reaction can occur. Here, the particular reaction cannot be explained or proceed. The chemical completion is also does not explain the first law, and here in second law, predicting whether particular reactions can occur, and if it's occur, then to what extent. In the other words, the second law of thermodynamics gives the conditions under which a portion of it may be converted into work. Here it does not explain, here also it is conversion of the work. The heat is converted into work also does not explain the second law of thermodynamics. The second law of thermodynamics is states in different way of the great variety of ways for statement of second law of thermodynamics. I will discuss second of thermodynamics in next class. I will stop here.